Good morning, sir. I am Navitha from CSCD section. My topic is about theorems and properties of Boolean algebra. Introduction to Boolean algebra. Boolean algebra is the mathematical structure that deals with binary variables and logical operations. It forms the foundation of digital logic design and computer science. The key operations in Boolean algebra are and, or, and not, which corresponded to multiplication, addition, and negation, respectively. These are the rules of the Boolean algebra. Basic operations. The primary operations in Boolean algebra include and, like conjunction or distinction, and not negation. And operations results in the only if both operands are true. Or operations results in if at least one operand is true, while not operation inverts the truth value of a single operand. Identity laws. The identity laws state that A and 1 equals to A and A or 0 equals to A. These laws shows that the identity elements do not change the value of the variable. They play a crucial role in simplifying Boolean expressions in circuit design. Null laws. The null law states that the A and 0 equals to 0 and A or 1 equals to 1. That means that any variable and with 0 results in 0 and any variable or with 1 results in 1. These laws are essential in understanding the behavior of digital circuits under various conditions. Idempotent laws. The idempotent laws states that the A and A equals to A and A or A equals to A. This implies that combining a variable with itself does not change its value. These law helps in simplifying complex Boolean expressions by reducing redundancy. Idempotent law means A plus A equals to A. A variable with itself always equals to the variable. A dot A equals to A. A variable and with itself always equals to the variable. Complementary law. The complementary law states that A and not A equals to 0 and A or not A equals to 1. That indicates that variable and with its complement yields false, while or yields true. These laws are fundamental in the design of digital circuits, particularly for creating logic gates. Distributive laws. The distributive law allows for the distribution of one operation over another, such as A and B or C equals to A and B or A and C. This property is vital for rearranging and simplifying Boolean expressions. It helps in breaking down complex logical operations into simplifier components. These are the distributive laws diagrams. The De Morgan's theorem. De Morgan's theorem provided a way to express the complement of conjunction and distractions. Not A and B equals to not A or not B. Similarly, not A or B equals to not A and not B. These theorems are crucial for transforming expressions and designing negated logic circuits. Absorption laws. The absorption law states that A or A and B equals to A and A and A or B equals to A. These laws illustrate how certain combinations can be simplified to a single variable. They facilitate the reduction of Boolean expressions, improving efficiency in logic design. The absorption law states that A or A and B equals to A and A or B equals to A. These laws illustrate how certain combinations can be simplified to a single variable. They facilitate the reduction of Boolean expressions, improving efficiency in logic design. Redundancy theorem. The redundancy theorem states that if a variable appears multiple times in an expression, it can be removed. For instance, the a into a b simplifies to a. The property aids in reducing the complexity of Boolean expressions. I am repeating the reducing theorem. The reducing theorem states that if a variable appears multiple times in an expression, it can be removed. This property is in reducing the complexity of Boolean expressions. Consensus theorem. The consensus theorem is used to eliminate redundancy terms in product of sums. It states that a b a c simplifies to a b v a c. This theorem helps optimizing logic functions. This theorem is very helpful to logic functions or digital circuits or any functions to develop. Duality principle. The duality principle in Boolean algebra states that every algebraic expression remains valid when unds and ors are swapped. This principle leads to new expressions and insights about existing ones. It highlights the symmetry inherent in Boolean operations. The duality principle in Boolean algebra states that every algebraic expression remains valid, unds and ors are swapped. This principle leads to new expressions and insights about existing ones. It highlights the symmetry inherent to Boolean operations. Applications of Boolean algebra. Boolean algebra is widely used in computer science, particularly in programming, algorithm design, and database management. It is essential in the designing of digital circuits, including microprocessors and memory devices. Furthermore, provides this systematic approach simplifying the logical expressions and analyzing logic statements. Boolean algebra is widely used in computer science. This is used in computer science, particularly programming. We are using Boolean algebra in the programming and algorithm design. Algorithm means to find the solution to the programming, and also database management. We use this Boolean algebra for the database management also. It is essential in the designing of digital circuits. This Boolean algebra is very essential for the designing for designing the digital circuits, including microprocessors also. We can use this Boolean algebra in memory devices also. Furthermore, it provides systematic approach. It provides the systematic approach for further any expressions or the further any programming applications. Conclusion. Boolean algebra is not just a theoretical framework, it has practical applications in technology. Further study can expand knowledge into more complex areas such as fuzzy logic and quantum computing. Engaging with Boolean algebra open doors advanced topics in computer science and engineering. Feel free to modify content to the structure needed. Thank you very much, sir.